Hey everyone, we're back at the PX4 Developer Summit. I'm your host, Ramon Roche. I'm really happy to be here. I have Jonas on the line. Jonas Vautherin is calling in from Lausanne, Switzerland. He's a software engineer at Auterion and a MAVSDK maintainer. He's a computer scientist from EPFL and has been involved in creating mission control apps and developer tools since 2014. He's a repeat speaker at the Dev Summit. He spoke at the first one at the ETH started last year. Jonas did a workshop on how to use MAVSDK. This session today is going to explain how proto definitions and auto generation can be leveraged to extend MAVSDK. This is a huge topic, guys. This is one of the main benefits out of the MAVSDK. I'm really excited to have you here, Jonas. Please take it away.
Hi, everybody. Thanks for being here and welcome to the Dev Summit. My name is Jonas Vautherin. I am working for Auterion. And in this session, I will be trying to give you a feel of what it takes to extend MAVSDK with new features. Because 20 minutes is so short, I will not be starting from zero and I will go pretty fast. So I'm assuming that you have some familiarity with MAVLink and MAVSDK. And what I will be doing is I selected a feature that I want to implement into MAVSDK, and I will be showing you how I do that. Before I start, I still wanted to go through a quick overview of what MAVSDK is. So at the lowest level, MAVSDK is a C++ library. It has very few dependencies and it's lightweight. And we made it such that we can run it on as many devices as we need, be it companion computers, Android or iOS devices, or whatever ground station we can imagine. Everything that one may need to talk MAVLink to a drone is inside MAVSDK C++. So what that means is that if you want to write a C++ program using MAVSDK, this is all you need, nothing more. Now, if you want to use another language, one of the language bindings we support, it's a bit different. So if we go one level higher, we have MAVSDK server on top of MAVSDK C++, and that guy is there to make the link to the language bindings we have. So MAVSDK server is an executable that uses MAVSDK C++ internally, and that exposes a gRPC interface to the language bindings. I will be focusing on adding a new feature to MAVSDK C++ and showing you how it propagates to MAVSDK Python, but it's the same thing for all of the other language bindings. Actually, most of this is auto-generated. All the language bindings, all of MAVSDK server, and the header files of MAVSDK C++. So when you want to add a new feature, what you have to do is define it into a proto file, generate the code, and then implement the MAVLink logic here. And that's it for the introduction. So let me directly go into a demo. As I said, I have chosen a feature that I want to implement, and that is not yet into MAVSDK. So that will be this one, do flight termination. What this does is it disarms the drone, and on PX4 it should open a parachute if you have it configured. Okay, so here I've got a terminal, and it's located into my MAVSDK repository. Just to show you, it's a Git. It's the Git repo, MAVSDK repo. So what you need to do if you want to generate code, first you need to be able to compile MAVSDK. So I already did it. So here I'm just running it again, and that's working on my setup. Then the second thing you need is to be able to run the proto file generator. And that's a script we have. So it's in tools and it's called generate from protos. So if I just run that, it's now failing, and that's on purpose because it has one dependency. This dependency is this proto cgen MAVSDK. And so I need to install that. But the good news is that it's available on PyPy. So you can just run pip install it. So let me do that. I like working with Python venv, but you don't have to. I will just be doing it here. And now I can pip install proto cgen MAVSDK. So this is necessary to generate all the plugins, all the code for all the language bindings and everything. now that I have it installed, I can run the generation script. It's going through all our proto files. You see the plugins here, action, calibration, camera, and it's generating the code for me. If I look at the git diff, nothing has changed here. I just have my new venv, but that's because I haven't changed the proto files. What I will do now is go into this proto submodule and edit the action proto file, because this feature that I want to add, do flight termination, I will call it terminate, and it's very similar to like arming, taking off, or actually even like kill, which disarms the drone. So I just decide that I will add it here. So the first thing I do is just write some documentation. So terminate will send command to terminate the drone. And then say I just want some definition. So this will run the terminate routine as configured on the drone. E.g., so disarm and open the parachute. Something like that. So that's my documentation for this feature I want to add. And then as you see, it's defined in the proto interface definition language. So a function is an RPC here. So I just copy, my function is very similar to kill. I just send the kill command and that's it. So I will imitate a bit that. So I have RPC and I want to call my function terminate. And then all of the functions need a request and a response. So I just terminate request and I return terminate response. Okay, good. Then an easy thing to do is to just like follow another function that's similar. So I've got kill. This terminate request is not implemented yet. So I will follow the kill request and see that here I want to implement the terminate request. Message terminate request. And I do for now exactly the same as kill, and I will comment on it later. Action result, and that's it. Okay, so in the request, that's where I would put parameters if I have some. So here I don't, but for instance, if you look at go to location request, it has 4 parameters, and that will be translated to the different languages. So I'm fine here, I don't want any. And the result is just saying that it could have an error message. It could, like the function could be denied, or I could have a timeout or something. So that's it. I just defined now the API for my new feature. Let me quit. So if I check, I have like the proto submodule has changed, and I can run the auto generation again. It's going through all the plugins, but what's interesting is that it went through action.proto. That one changed. The other ones did not. Once it's done, I can check again, and I see that now like action-related files got generated, modified at least. So it's all good. All those files I will not have to touch. They are all auto-generated files. But the thing is, as I said, I still have to implement the MAVLink logic somewhere, right? What I like to do is follow the compiler, right? So I just compile and I see where it crashes, because it has to crash somewhere. And here it says in action.cpp, which was auto-generated just before, it tries to call imp terminate async and imp terminate, and it doesn't find them, of course, because I did not implement them. So the file where they should be implemented is in the implementation of action. Let me go there. So plugin action, and I should have an action imp. Let me go to the header. Same as before, I just go to kill and I look a bit around and I see that, yeah, terminate is something that should be similar. It has a result, an action result. It's called terminate. It doesn't have any parameters, and that's it. And in C++, we have blocking functions and non-blocking functions. This one is the blocking one, but if I look for kill, the other one here is also the non-blocking function, the async one. So I need something similar here. So I just define it. And the compiler error before was actually complaining that it was looking for that. So it has a result as well. under a form of a callback this time because it's async, and that's it. So now I solved those errors, but I only edited the header file, right? I need to write the implementation now. Same thing, I want to go close to the other similar feature here. And what I can see is that this is the blocking function, and what the blocking function is it creates promise and a future. It runs the async function, it iterates for it. So I can just do exactly the same thing here. So let me just copy it and change the kill function for terminate again, and that's it for that. So I just implemented the blocking function of terminate. That was easy. And now I want to go check the async one. And this one is actually the MAVLink logic, right? It's defining a command, it's setting some parameters, a target component ID. So that's the thing I need to implement. So same thing, it's just terminate, it's called terminate async, and it takes a callback. Okay. Now it's a command as well. So I just define my commands. And I need to set what command it is. And so for that, I go back to the documentation and I said, that's this one I want. So let me copy it here. Next step is the parameters of it. So command.params.param1. I know that there is one parameter here. Param is called terminate. And it's activated if bigger than 0, and it has to be 0 or 1. So I need to set it to 1. And there's no other parameter. Fine. So here I just set it to 1. And then the next thing that I need to set is the target component ID. That's necessary for a command. Target. All of this is really MAVLink logic. If you know how MAVLink works, that's just how you would define a message with any MAVLink library. This parent object I use is a helper given to you by MAVSDK. So in this case, it gives me the Autopilot ID, which I use as the target component ID. And then if I look at the other one, the last thing it does is just sending the command async. So I just copy that. That's the same thing. That's my command. Great. So now I implemented terminate and terminate async. And that should be it for compiling, right? Let me try that. Okay, so it's compiled and it installed it now. And if I look at my git diff, I see that this is what I just implemented now, and all the rest got auto-generated. Great. So I prepared a small C++ example. I put a label at the top. So you see it's an IDE. And this example will not be working. It's missing a few things. But what I want to show is the auto-completion there. So it's depending on the MAVSDK I just built and installed. So if I compile it now, I should be able in my action plugin to just do action.term and I get terminate. As you see, I get both the async one and the synchronous one. So that's it. We just implemented a feature that is now available in C++. From the auto generation, we got for free the implementation of MAVSDK server. So that should be it now for the MAVSDK server side. Now, one thing is we have this proto file that we edited. So let me go in the proto repository. And that's the diff we made. Now I will be wanting to propagate that to Python, right? So I need to somehow get it into the Python repo. And the Python repo also has this proto repository as a submodule. So what I need to do is push it. So I prepared already my branch, that's this one. And I will just add terminate for dev summit demo, something like this. And I just push the branch. Okay, so what happens here was not planned. If I look at the remote, I'm on the HTTPS remote. So let me just get remote. Update the remote so that I can actually push. Okay, let me do that again. So you don't need to have any special rights. You could just have a fork of the repository, and that would work for you. You don't need to be a maintainer or have any rights there. Let me just go check there. So I just pushed my branch now, and I'm not logged in. Demo. Let me do it here. Demo effect, sorry. So that's what we changed now in the proto repository, just the new function. So what you would do now typically is just add us as reviewer. I can just add Julian and say that's the new function I added in the dev summit demo. And if Julian is watching the presentation, maybe he can review it now, but we don't need that, right? So now let me go to another IDE I prepared. This time is for MAVSDK Python. And I have PyCharm here with a small example that's that will create a system, connect to it, and then set the takeoff altitude to 20 meters, arm the drone takeoff, and then wait 10 seconds. And what's missing here is I would like to be able to do a wait drone.action.terminate. But as you see, it's not auto-completed. So if I try to do land, I get the auto-completion with the documentation that we had in the proto file, but I don't have it yet for terminate because I need to generate it. So let's go check this terminal I have. Now, what we have here again, we have the proto submodule. So let me go there. And if I fetch, I should get the, the dev summit terminate. So let me check out into this branch, dev summit terminate. And we have now the commit we just did before for C++. So I can go back. And this time I already installed proto C gen MAVSDK, as I showed you before, so I can directly run the auto generation script. For Python, it's in other tools, and it's called run proto C. So it's the equivalent to what we have in C++, but now it's generating the Python code for all the plugins. And that's it. I should be able to install it locally. And I can go back to my example here. Theoretically, it should have updated, and now I should be on the latest, on the latest version of MAVSDK. So if I do drone.action.terminate, it now exists. So it was just completely auto-generated, and it appeared in the SDK. Good. I still have a few minutes. The goal was to really show you that it's working, and I hope it does. So let me save that and go to my my environment, my simulator environment. So down there on this shell, I'm inside MAVSDK that we just like built before, and we installed it. So we installed it into build default install, which means that it should be here. So in bin there, I've got MAVSDK server. So I need to run it, and I run it on port gRPC port 50,051, because that's what the Python example we have will be connecting to. So now it's waiting on one side on this port for the MAVSDK Python example to connect, and on the other side it's waiting for a MAVLink drone to connect. So let me start a drone here. It's just like normal gazebo with some model and some world. It should take a few seconds to start. And okay, I should be set up now. So we have a drone here. We have the Pixel shell, and we have MAVSDK server waiting for MAVSDK Python to connect. Let me just quickly try it. So I come under takeoff to see if my simulator is working. And let me land again. So Seattle is working now, which means that I can go back to my MAVSDK Python example and run it. So let's just quickly look at it again. It will connect to MAVSDK server running on localhost port 50,051. It will connect to it. It will set the takeoff altitude to 20 meters because we want to see it, fall after the termination. It will arm takeoff, wait 10 seconds so that it has time to take off, and then it will terminate. Okay, let's run that now and go here. So it's taking off, and now it should be waiting for 10 seconds, and at the end it will terminate, and we'll see what happens. Awesome. It just terminated and opened the parachute. And now it's landing. Good. Let me stop this now and go back to my slides. Nope. Okay, so that's it for my demo. To conclude, I know that I probably went pretty fast, but I hope you got a feel for what it means to add a new feature into MAVSDK. The main point here is that all you have to do is add a C++ MAVLink implementation and the corresponding proto API, but the rest will be auto-generated for you. So you don't have to know any of the other language. You don't have to know Go to add a feature to MAVSDK, but it will still be propagated to Go. And maybe the last thing I'd like to say is if Julian is watching the presentation, maybe you have a new PR to review. Thank you.
Thank you, Jonas. That was excellent. Thanks a lot for your presentation. Why don't you head to Slack and help our community with a few questions? I think there's a bunch of them for you there. Thank you again.